Okay. Hello, everyone. Welcome to the next session of the Coding Battleground. This is our sixth session. As you already know that, okay, in this program, actually, our two coding competitor actually compete with each other. They try to solve a problem, and whoever solve the problem in less time complexity, that will be the winner. And maybe if they are taking the same time complexity, if their code are taking same time complexity, in that case, whoever will solve the problem earlier, that will be the winner. And meanwhile, they will solve the problem. There will be a quiz for our audience also, and whoever will be the winner from our audience side in the quiz, that will also get a coupon from Geeks for Geeks side, and runner up also will get the coupon. Okay, so there will be two winners from our audience side and one winner from our coder side. Okay, okay, so you can ask your friends to join. Sanik, I'm fine. Okay, let me call my today coder actually. Hello Yash, how are you?
Hello, sir. I'm fine. How are you?
I'm fine. I'm fine. Yes, actually, maybe I think many people already know you here, but still, there may be some new people here. So, will you please introduce yourself to the audience?
Uh, yes. Hi, everyone. My name is Yash Dwivedi. Currently, I'm pursuing BTech. Currently, I'm in my third year, and I am an associate mentor, intern, and a technical content writer at Geeks for Geeks. Besides this, I'm also five-star on CodeChef and expert on code courses. So, this was a small introduction about me.
Okay, okay. So, let me call to Chirag now. Hello, Chirag. How are you?
Hi, sir. I'm amazing. How about you?
I'm fine. I'm also amazing like you. Okay, last session was very amazing with you. Actually, I still can remember.
Thanks.
So, will you please introduce yourself to the audience?
Okay, so my name is Chirag Vaishnav, and I'm also currently in my third year pursuing BTech from LNM IIT Jaipur. And you might have seen my videos for the DSS self-paced course in the project section. So I'm not basically more of a competitive programmer, but I love DSA, right? So this was a bit introduction from my side. Also, I'm associate mentor at Geeks for Geeks.
Okay, okay. So you can actually,
Hi, Chirag.
Hi, Yash.
All the best for the session.
Same to you.
okay. So let me share the question as usual. Let me share the question with you people. Today's session question. I think I need to open it. Need to. Okay. So let me share my screen. So I hope the screen is visible to you people.
Yes, it
Yes,
is
sir. It
visible.
is.
Okay, okay. So this is our session six actually. This is just to show you that okay, this is the sixth session of Coding Battleground. And today's problem name is the path sum, which is from the actually from the Google. And this is very nice question actually, and you will enjoy. Okay, let me read the statement for you. Problem statement. So you have a tree with you whose depth is 5. Okay, and there will be an input given to you in the form of an array. The input will be of 3-digit integers. Okay, so what is the use of that? Let me tell you. So we have a tree which is have depth smaller than the 5. Okay, and this tree can be represented by that array, and the array is made up of actually is having 3-digit integers. So out of these 3-digit integers, each integer actually in each integer, 100th digit represents the depth of the node of a node actually, and that will be between 1 and 4 because the tree depth is less than 5. And 10th digit actually 10th digit represent the position of this node, okay, in the level it belongs. That will be from 1 to 8, and the position is the same as the full binary tree. Okay, the unit digit place actually represent the value v of this node, and the value will be from this to this 0 to 9. Okay, so let's take an example, and from there this will be easy for us to understand. So you will be given an input like this. This is the input array. So in this input array, actually this input array is representing this binary tree. So let's try to relate it. So one thing is, see, this is showing 113. See, this is one. This one means, so this three means I'm talking about actually this node. This node is at the first level or depth, you can say. This is at the first level depth. Okay. Yes, that is showing the depth, and this is at the first position itself. Okay, so let's see what this number is. So this is showing that, okay, this is a this is our node which is having value 5, which is at the level 2, which is at the depth 2, and this is at the first position at this level. At this level, first position is this, second position is this. Okay, so this is at the first position. Similarly, here you can see this number is representing this node actually. So value is 1, and this is at level 2 or depth 2. This is depth 2, and the sequence, you can see the position is 2 itself. The position of 5 is 1. This 1 is 2 actually. Okay. So what you need to be done is, you need to print the what you need to be done is, you need to let me see. Okay, you need to print the sum of all the paths from root to the leaf. So like one path is going from here to here, so the sum of this path up to the leaf is 5 plus 3. Okay, and another path is going from here to here up to the leaf, from the root to the leaf. So the sum of this path is 3 plus 1. Here you can see. So total sum is 12. So your output should be 12. So question is little bit complicated, but let me take one more example for you people. So one more thing here is that all the input is given in the form of ascending order. Okay, all the three-digit number are given in the form of ascending order. They will be in ascending order actually, because we need to represent the numbers. Because first you need to write the root node. For that, 100 digit will be smallest one. Okay, these are in increasing order. Okay, increase in ascending order. That's it. So here, if you have any doubt, you can ask in the question actually.
Um, Currently, it seems to be clear. Like we just need.
Okay,
I think we just
let me,
need to build the tree from the data, and then we need to find the path sum. Like we
yes,
need to
yes.
find the sum all the
You
paths.
need to find the sum for every path from root to the leaf. From root to every leaf, you need to find the sum of that path, and you need to add the sum of every path.
And suppose just there is just one root in that case, we just need to return the value of the root.
Yes, yes, yes. So let me take one more example. So can you people tell me, okay, for this type of tree, what should be the output? So this means this will make me clear that, okay, question is clear to you. What will be the output for this tree? So what will be the output? Can you people tell me? So what will be that sum from root to the leaf? Am I audible to you?
You are asking me?
Any one of you?
Yeah, the
Yes.
output will
Chirag,
be 4. I
yes.
thought you
Four,
told the
four,
audience.
four.
Yeah, that will be 4.
Yes.
Chirag, I think that is clear. 4.
Yes, yes.
So input will be given in the form of array only. See here, you can also see the value, at the first depth. One is representing depth here. Let me write here. Actually, I also don't have writing pad right now with me. So this is depth. So we are counting that, okay, this is first depth, this is second. Okay, Otherwise, in some books you can find out this is what, this is zero, even zero one, that they start with zero, but we are starting with one. Okay, and this is it at this level. Actually, this is the first element. Okay, so and the value of that this node is 3. So for this, okay, if I tell you the value is 3, one is value. Let me try to write value.
So basically, every element, every three-digit number that you're giving me. So the very first, the what you can say, the leftmost digit is telling me its level or depth. The middle digit or the second digit is telling me about the position, and the third
Position.
digit is telling me about its value. That is the rightmost digit is telling me about its value, right?
Yes,
And
yes,
like you have given all the notes in such a format, and I think I need to construct the tree, and then I need to find the sum of all the paths from root to
yes, yes,
leaf, right?
yes, exactly, exactly. So so that's great. That's great. Chirag, if you can also give me a note that okay, the question is clear. One thing is sure. Yes, the question is clear to you. Okay,
Yes,
what about
totally.
Chirag?
The approach is same as Yash said, that what we have to do from the given array, first we have to build a tree, basically, that how we can
You
iterate,
are telling me.
right?
Okay.
And from that we have to calculate the paths. And so the first hurdle is to convert it into a tree.
Okay. Okay, you are telling. Okay, so yes, you can also. Okay, let me remove the Chirag here. Yes, will you please again tell us? Okay, any idea which is coming in your mind to solve this problem? Any first idea which is striking in your mind?
Oh, okay. So when looking at the question, like every node is represented in form of a three-digit number, like you said, right? So if I have a particular, can I just maybe share my screen so that I can maybe explain what I might be doing or something, what I'm thinking?
Yes, 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 please, yes, please.
Okay, so let me just
Just
share.
basic idea, just want. I want.
Okay. So is my screen visible? I guess it is visible, right?
Yeah, that's
Yeah.
it.
So what I
That
am
is.
is it visible?
Yes, 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 yes.
Uh, yeah. So, like as you said, like you will be whenever you give me let's say you are giving me some values, right? So you are giving me all the notes. Like if I have, let's say, n notes, right? They would be ultimately they would be n notes. So if there is one note that is 113, so you said that this particular digit, the leftmost digit, will be telling me about the level of that particular note. This will be telling about me about the position, and this one would be telling me about the value of that particular node, right? So,
Yes,
like
yes.
in this case, and let's say if I had something like a 2, 1, and 5, right? So this node would be telling its level. This would be telling its position, and this would be telling the value, right? So if I just make another one, so like 2, 2, and let's say 7, if I make something like this. So if I have a tree like this, so this for this particular the first level, I do not have positions, like I guess, right? Because there is just one position. So here the position is not mattering, but here as I can see that if I have this digit and this digit, so the position is mattering to me. Like if I'll
Yes,
convert this 113 into a node, so the value is 3. And since it is at the level 1, so the level, as you said, is starting from 1. So this will be at the very first level. Then next up, if I have 215, so I know that 1 is the position, like 2 is the level of this particular node. This particular node is 5, and since it is position is 1, so I can have two nodes at the second level, right? I know that for sure because in the question it was written somewhere like full binary tree or something like that, right? So in that case, I'll have first this position and second this position, right? So for this, what I can do is like I have to store it like this. Like I have to bring this and I have to connect this three to this uh, 5 like this, right? And then 2, and 7. So that means the level is 2, the position is 2. So this is the second position with respect to 3,
yes, you are right.
right? Second level. And then I'll have the node 7. Assume that maybe I had something else. Let's say if I had maybe 3, and let's say the position was also 3, the level was 3, the position was 3, and let's say the value was something like a 2, right? Let's assume this. So in that case, like I can see that if this was a full, like in your question you mentioned that as you have to assume the positioning and according to the full binary tree. So that would mean that if I had another level, so it would be like this, right? So this would be the position of the first node, this would be the position of the second node, this would be the position of the third node, this would be the position of the fourth node. But what
Yes,
you
yes,
have given me is this particular. If you have been assuming that you have been given me these four nodes, right? So this is the fourth node. If I have 3, 3, 2, so that means that I'll not be having this node, I'll not be having this node. Like what node I will be having? So if I have this particular node, right? So if I'll try to decode it, so it seems that this particular node is of value. The level is 3, so that means that the level is 3, and I can see that I'll be putting it level 3, but the position is 3, right? So this is the position. So I can see that this was the first position, this would be the second position, this is the third position. So here is where I'll put it, right? And whatever the value is given, so here I assume that the value is 2. So if the value is 2, so I'll do it like that. And the challenge here is that I can see that if I'll be given all the data, since I'll be given the data in the sorted order, so I'll not require any sorting, and the data needs to be given in the sorted order. Only then I'll be building it, right? Only then I'll be able to build it. If it was given very randomly, then it would have been pretty difficult to define the parent and the child relationship. Now in this question, the thing is that once you like, there are two challenges I can see. First of all, you are giving me all the end nodes in form of a array. So what you are saying is, you are saying that I give this as one node, this as the other, this as the other, and this as the last node, right? So I have to first convert all these value 3-digit numbers into the nodes. I have to retrieve the value so that I can see what is the speciality about each node. Then I have to build the tree. Once I've built the tree, so maybe I can apply a DFS or a BFS approach to maybe just find all the path from root to uh, leaves, all the leaves, right? So this is what I'm thinking.
Yes, that's a nice idea. If you will apply the BFS, the time complexity will also reduce actually. Okay, okay. So let me now you can start coding. Yes, you can start coding, and
Okay, sure.
let me talk to the Chirag. Chirag, what is your idea? How you are going to solve this problem? Just a basic idea. I want just what first comes in your mind. That thing I want to know.
See, the first thing that came to my mind was the same thing that Yash has explained. So also Yash has
Please don't
explained so
copy.
beautifully that it also cleared my vision about the question.
Okay, uh, you're not going to use the same approach. Are you are you using the same one?
Let's see what comes to the mind. But
Okay, okay.
till now, what I am thinking is actually he basically explained the question that he explained, that what we are thinking, right? And then how we can form the tree, right? So the same thing was coming to me as well. So so there's nothing more to explain as much. So I will also try to implement it, right, either in BFS or DFS. So let's see what comes to my mind. So I will just take pen and paper and draw it down and just try to
Okay.
analyze that how I can implement this.
Okay, okay, you can try. You can try. Let me add all of you. And you people, please share your screen, coding screen with me. You have not shared with me. Please share your coding screen as well. And let me try to open my quiz so that actually we can go for quiz round. Uh, Let me check out. Meanwhile, you can start coding, and I'm showing the. This is, I think. So this
Is my
is.
screen visible?
Yeah, I think yes. This is your screen. Yes, this is your screen. Your screen is now visible to the audience. Okay, you can code here itself. Meanwhile, I'm checking for the quiz part. Okay, so I'm sharing the yes screen to the audience so that they yes, whatever you're writing, will you please keep explaining to the audience so that uh,
Right,
they will
I'll
also know that
make.
okay what you are trying to do. So meanwhile,
Right,
I'm
so
trying to connect with my quiz. Actually, I'm having some problem in the quiz. Let me, whenever I will be connected, I will come back. Okay.
okay, sure. So what I'm thinking is, first of all, I'll be given all the values, right? So I'll be given int n and maybe I as well, right? So I'll be taking first of all the 3-digit numbers. So I'll take that input in a vector. Is my screen clearly visible? I hope that it is. Right. So in the audience can let me know. Right. So what I'll be doing is, I'm
You
thinking
can
that
increase a little bit phone.
okay, I'll increase it. Does is this good?
Yeah, that's nice. That's nice. Very nice.
Okay, so what I'm thinking is, first of all, I'll take all the values as an input. So I also maybe need to declare vector or an array or a list in Java. That is basically what I need to do. So I might need a. Then what I'll have is I'll store all the 3-digit numbers. So for I starts from 0, I would be lesser than n, and then I can do an I plus plus. I can simply take all the values that would be given to me. What are these values? These values are, as he mentioned, like all the n nodes that will be given to me. So I all the information of the n nodes, they will be represented by a 3-digit number. So I'll be taking all of them as an input. After that, like what I can do is I can make a function, maybe something like a path sum or something like that. And in that function, what I can do is I just simply need to find the sum, right? So I can pass my vector into it, and maybe that would be sufficient, right? I can pass my vector, and this would give me the path sum, right? So what I can do is maybe int answer is equal to path sum, and in the end, I'll be returning the answer, right? Is this much part clear to everyone? I hope that this much part would be clear, right? Now the next of the thing that I wanted is like I'll be having a function, right? Maybe I have a int path sum function. Uh, so maybe this thing, right? So it will be returning me everyone's. Love you, sir. Arey, what are you writing? That's great, right? So vector of maybe int and ampersand v, right? Let's say ampersand a or something. Maybe v I can declare so that it's just differentiates. Now I'll be having all the vectors. Once I have all the vectors, so what I can do is I need to store the number that I'm having. I need to store it, right? Like what will be given to me? Let me show you. Like I'll be given this particular digit, right? If I'll be given 113, like let's say I'm given something like this. Let's say that I have been given something like a 113, right? If I've been given 113, in that case, what I need to do is the first like the first value or the v of i, uh, first v of I would be what 113, right? This would be the number. So what I need to do is I need to extract all its digit, right? I am thinking that first of all I need to extract all its digits. So first of all, if I have this number, so what I can do is like maybe I can store it on a number n is equal to 113, right? If my n is equal to 113, then definitely I can see that I need to extract all the digits. So if I do n mod 10 here, so I'll get 3. If I divide this number by 10, so it would get updated to 11. Then again, if I do n mod 10, so I'll get what? I'll get what? Maybe I'll get a number 1. That is this particular position. So this is nothing but the value that I'm getting. First of all, if I'm extracting the first, the very rightmost digit by modeling it by 10, so I'm getting the value. Then I'll get this position, and then after that I divide n by 2, so I'll get something like a 1, which is the this digit, and then I do n mod 10. So in that case, what will I get? I'll get the 1 again. I'll get 1 again, which is this level. So this will give me the level, right? So this is how I'll be having my tree. Now the thing with this question is that once I have extracted, right? Let's say that I extract all the information about a particular node. So like as I said, like if I assume that if I had something like a 3 3 and 7, right? So that means that the level is 3, like the level is 3, and the position is 3, right? The position is 3, and this value is 7, right? So this is the value of the node. So as I said, like let's say you had something like this, and like some information here. So this node would be inserted here, right? This particular node 337 is here, right? This at this particular position, like this is the node, right? This particular node 337 is this node, right? So in that case, I need to build a relationship, right? Now the thing is, the challenge that lies ahead of me is that can I build this particular tree? Because also one more thing that sir has said is that I will be given all the nodes in ascending order, right? So let's say I was given 113, let's say I was given 215, and let's say I was given 22, and maybe something like a 22, what you can say 3, or and then I'm given 3 3 and 7, something like this, right? So if I've been given this, so I want this particular number to be here, this 3, this 5 to be here, this 3 to be here. Like once the challenge here is again to build a tree. If everyone agrees with me, so you can give me a +1 in the chat, right? Up till now, if everything is clear, so you can give a +1 in the chat, and you can also like the video so that I can keep on moving ahead, right? Is this much part clear to everyone? Like up till now, what is the question saying? As sir has told me, right? So this is what I'm thinking up till now. So up till now, what whoever is satisfied with what I'm thinking, so you can let me know. And if you have any questions like up till now, what I'm thinking, so you can let me know so that I can answer that, and then I'll be moving ahead with my approach, like what I can think of. Okay. All of you can just like the video and give me a +1 in the chat if all of you are clear with this particular part, right? Up till now, if everything is clear to all of you, then you can give me a +1, right? So once I have this particular tree, right? So once you can give me a +1 in the chat. A quick +1 in the chat would help. Meanwhile, sir is maybe trying to fix some technical issues. So until then, I'm explaining my approach. So if I have this particular tree, you can give me a +1 in the chat so that a little acknowledgement would help, right? Okay, so this is what you have to do. Like this was the tree, like 2 to 3. So if this tree is there in front of me, so I want to build it, right? So I said that I can extract all the digits, right? But how does that help me? How does that help me, right? Lalit is saying +1. Or what about others? Others can also give me a +1 in the chat. So I know that this question is clear. Like this question seems a little bit tough to me as well, but I will try to decode it. Like I'll try to see like what we can do with this question, right? What about others? Others are also clear with this question. Like this, if this suppose this was the array given to me. Now the thing is with this question that I am
I
stuck
think
here. Yes, yes, sir. You were
I
saying
think quiz is not starting. There is some problem. Still, I will keep trying for that actually. Uh,
till then maybe I can explain my approach, right? So what
yes,
I'm thinking,
you can work on your code itself. Okay, both of you
yeah,
actually.
right. So what I wanted to say is if I once I have this particular tree with me, so what I needed to do was that I needed to build this tree, right? The challenge here is that I will extract the data, but how will I build the tree? So one more thing that I can notice is what I'll be getting is like if I just draw all the three digits. So these were the three digits that would be given to me. The first digit, uh, the question is saying that you will be given the question is saying that you will be given n nodes of a tree, and that particular node would be telling the first digit would be the very leftmost digit would be telling me the level of that particular node. The second digit would be telling me the position of that particular node, and the third digit would be telling me back forward the video. Yeah, right. Left should left should less than root and right than root. Nandan, what you're saying, you can explain me a little bit, right? So what I'm thinking is this will be the value, right? So I can extract all these three values. But what is the like for a particular node? What is the unique thing? Here, the unique thing about every particular node is like is here's as in the question, sir has mentioned that this will be a binary tree, right? This will be a binary tree. So that's how it will be. Like once I have all the nodes, so what I can do with this thing is if I have all the nodes, right? So if I have all the data extracted, let's say for the very first node I've extracted all the data, right? So how can I uniquely identify it? So what I am thinking is either I could build an adjacency list, right? I could build an adjacency list, and that would help, right? Adjacency list defining these connections, right? And I can do that, but there's a challenge with that as well. Like I can build that, but that is a little bit difficult. That seems a little bit difficult. But what I can see is that for every node that I'll be given, I'll be having its level, I'll be having its position. And if I have for a particular node, if I have its level and if I have its position, right? So what I can say is I can uniquely determine its position. I can uniquely determine its relationship. How I can do that? So let's say I'm a particular parent, right? I am at a particular parent. Let's say if I'm at a particular parent, then if I my current position is pause, right? If my current position is pause, let's say, and I have a left child and I have a right child, okay? So currently assuming that my level is level, the parent's level is level, and the child's position the parent's position is pause, right? If the parent's level is level and the parent's position is pause, right? So in that case what will happen if that is the thing, then I am assured that the child's that if I am want to go towards the left child or the right child, then I need to do level +1, then I can move to lower so that the children would be accessible to me, right? My immediate children would be accessible. Now if I just directly move to level +1, that would not tell me that who are my children, right? I cannot directly move to children. Like if I'm thinking about building the tree still, right? So if I have moved to level +1, even then I will not be able to do something productive, right? But if I have this position, can I use this position? So as sir has mentioned that I'll be given this particular binary tree, right? So as he has mentioned, like if I want to do it like this, let's say if the this tree looks like this, something like this, if this tree look like this, so if the position of this particular node is 1, so the position of this node is 1, this node is 2, right? Let me write it for all of you a little bit in brief, right? Let's write it in a little bit of brief. So you can just give me a +1 in the chat if up till now things are clear to all of you, right? So what you're saying, pause of node means its parent will be position -1/2. Yes, you can say something like that, possibly, Ayush. Index in the binary tree would be 2 to the power level plus pause. I'll explain what I am thinking. So what I'm thinking is if I have a particular node like this is the tree that's been given to me, assume, right? So what I want to say is that the position of this node is 1. So what is the position of its child? The left child is 1, the right child is what? The right child seems to be 2. With respect to this particular parent, its position is 1, its position is 2, its position is, the position of this child is 3, and the position of this child is 4, right? You can write agree in the chat if you agree with me on this much part, right? If you agree with me on this much part, you can give me a +1 in the chat, right? So if I say that the position, let's assume that the position of this child is position is what? 2, right? For this particular node, what is the position? The position for this particular node is 2. Now the challenge is that how will I determine its parents? How will it I its level is, let's say its level is lev, right? Its level is lev. So if I want to move to its child, so I'll just move to one level down, so that would be level +1, and I'll move to one level down, but still I'll not be able to access the parent without the position. So if my position is 2, then what is the position of the parent? The parent's position seems to be 3. So if I can build a relationship with this, like currently here the position is 1 and the child's position is 1 and 2, right? So if I were to think in this direction, so what I can do is, if my current position is pause, if my position is pause, and I subtract 1 to it, and then I multiply 2 to it, and I add 1 to it, so I can move to the left child. How? Like if I have to explain this particular thing, so if you will look a little bit more deeply into this question, as he has mentioned. So like if I am at a particular position, right? If let's suppose you are here, right? If your current node is this, and like if your position is 2, if the parent's position is 2, then the child is 3, right? If the parent's position itself is 2, then the child's position is 3, and this child's position is 4, right? I have just magnified this thing, I have just magnified this particular segment, right? This particular segment, and I'm trying to find the position. So if my position is 2, if my position is 2, then I have to find the position of the child, my left child and the right child. Okay. So if I can see, so if my position is 2, then what if I do something like this? If I do position -1, and I multiply 2 to it, and I add 1 to it, so I can move to the left child. Because if the position is 2, so that means 2 into 2 minus 1 plus 1 would give me 3. So the position would be 3. And if I want to move to the right child, so what I can do is 2 times position -1 and +2, right? Like this, and I can move, right? Is this part clear to everyone? How am I moving in like this direction? Basically, what I am doing is, if you remember about the concept, so this concept is coming from nothing but the concept of, like, if you have idea about segment trees or something like that. So like what I'm doing is, basically, if I have a node here, and this is getting connected, after this node is there, this node is there, right? Let's say these are the nodes that I have, and let's build a tree of complete level 4. So in this particular case, if I'm building this particular tree, so the thing is with this tree, that this position is 1. So with respect to this, the position is 1 and 2, right? Now here the position is 1, 2, 3, and 4, right? Like this. Here the position would be 1, 2, 3, 4, 5, 6, 7, and 8, right? Since the position has been given to me in the one format, right? So if whatever at the current position I am at, let's suppose that this was my current position, right? Let's suppose that my current position pause was this, right? Pause was 2. So if I have a level L, if I have a particular level, so if I want to move to my child, if I want to access my child, then I'll need to move down. So I'll move to level +1, right? You can write a +1 in the chat if you agree with me on this much part, right? Okay. So I can move to the child, so I can move to level +1. Then what I could do is, I could move. Then I need still one parameter, right? That is the position. Only then I'll be able to access my children, right? If, like, it should not happen that if I'm at this node, so I should not access this or this, right? Because this is not coming in my path. Actually, this 3 and 4 are my children, right? So what as I said, that I can observe one pattern, that if the parent's level is level, right? If the parent's level is L, right? If the parent's level is, let's say, L, if the parent's level is L, then the child's level will be L+1, right? And what I can think is, if the parent's position is pause, then the position of its left child seems to be 2 times pause -1 +1 to me. Like, you can also make anything. And if I'm moving in this direction, so it would mean this. Like, if this is the child, let's say if I am at 4, let's say like this. If the position is 4, then the position of this and this child, let's see what's the position. So I've just magnified this part. So this would be 7, and this would be 8, right? So in this particular part, what I can easily observe is, like, you are saying position in -1 and position +1. That can help or no? Yes, that can also be helpful, right? That depends on you. You can build the relationship of the position. But like what I thought was 2 times position minus 1 and plus 1 for the left child, and 2 times position minus 1 plus 2 for the right child. Like this is what I was thinking. You are also saying, right? Basically, you are saying that if the level of the parent is 4, so its child would be 2 times I minus 1, 2 times position minus 1, so it would be 7, and this would be 8. So that will also work. But I was thinking in this direction. So we can use anything, right? If up till now things are clear to you, so now we have defined the relationship between the parent and the child as well, right? Do you agree with me? All of you agree with me that we have defined the relationship between the parent and the child as well. Like if I want to go down the tree, right? I want to go down the tree. If I have this particular tree, or any tree for that matter, if I have this particular tree, then what I want to do is I want to move down, right? I want to move down. I always want to hit the root. Okay, I always want to hit the from the root. I want to hit the leaf, right? From the root node, I always want to hit the leaf node, right? This is what I want to do. So for doing this, I always need to access my from a particular parent. I need to access my children, right? I from a particular parent that I am at, I want to access my children. And if I want to access my children, so for that, what I can do is, if if suppose this is the parent, this is my parent. So if its level is L or LEVEL and its position is pos, so as I know that if I want to go its children, so its unique point would be level plus 1. And if I am going to the left child, so it would be pos minus 1 plus 1. As you I am assuming this, you can assume anything else. And this level would be nothing but level plus 1, and this position would be 2 times pos minus 1 and plus 2, right? Like this. Or you can maybe, as you mentioned, like if the position is pos, then the
Okay.
position can also be 2
Yes.
times pos minus 1 and 2 times pos. Yes.
Yes. Yes. You need to wind up. Actually, we have quiz code with us. So
Okay.
I cannot share the quiz, but people can attend that actually.
Okay.
Let me tell. Okay, will you please? You can work on your problem. Okay, you can work on your problem, please.
Yes,
Let
I
me
will
share.
start for you.
Yeah, I'm sharing the quiz code with the audience now. That code is with me. So the code is like this: 78519854. I'm trying to write it here also, but it's not going in the chat. So let me announce it once again. That is not showing. 78519854. So from the audience, can you please confirm me? Is the quiz is now active or not? Please confirm me. From the audience, please. You people can start. Please finish your coding. You people please finish your coding as early as possible. We already late in this session. So quiz is started or not? Please confirm me. Let me give you the code again. So quiz is started actually, but that is started by one third person. That is not started by me. That's why I'm not able to show you that thing. Full link of the quiz. Okay, let me ask to the concerned person to share the full link of the quiz. Otherwise, the code is 78519854. You can go to menti.com, and there you can use this code. I'm repeating the code, and so the link is with me. Let me share the link also with you people. If that become possible, actually, that is not post is not going from my side. So I'm not able to share the message also. I don't know what happening. So, uh, yes, can you share the code if I provide you the code?
Yes, you can share me the code. I'll provide. Like you can share in the private chat. I'll provide it.
Okay,
Yeah, right. I'll just submit. Just give me a second.
I don't know something is.
Uh, Guys, let me know if the code is visible. I have just pinned in the chat. It should be visible in the chat, I guess. Uh, Sir, I think the code is visible in the chat.
Okay, let me see. So, which link you shared actually? This was the second link actually.
Okay, so
Okay, we have shared screen. Let me share this also. So, I'm connecting with actually Chinmay. Chinmay will okay. Chinmay, will you please? So this is the quiz in front of you people now, and you need to fill little description about yourself. Yes, I think you need to share the second link. You share the first link of the quiz.
okay.
Okay, okay. Okay. The link is shared by the Chinmay. Okay, okay. That's fine. That's fine. That's fine. Great, 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 great. Everything is going fine now. Okay, you people need to fill the description. If you have done it, you can write +1. Then I will move on. You need to provide me email ID so that the winner can get the reward. Actually, if you have filled the description, then we will move on. If you are in the quiz and you have filled this description, I'm talking to the audience. Then please write +1 so that we can move on. So Ishant have already filled this description. So let's move on. We can move on to the next screen and we can. So let me ask to the Chinmay to uh, actually on the keyboard. If you will press the arrow button, next arrow button, Chinmay, if you will press the arrow button, then you will move to the next or next actually next slide, next quiz question. Below the shift button, there will be a so okay. So okay, we are at the next. Sorry for the problem here. Little bit we are facing the problem. Actually, I am not able to share the quiz at my end. So I am taking the help of someone else. So that's why actually this little bit problem is going on. Okay, I think there is some network problem also at the Chinmay side. So, okay, Chirag, let me share your screen. Okay, you have Chinmay have already shared the screen. Okay, so this is just a guess for you people who will win, and please fill your entry as soon as possible so that we can move to the next question and we can finish this quiz. We now finish. We are also facing problem in this quiz, so we want to finish it as soon as possible. So the ID, let me share with you from audience. Kong is asking for the ID. Let me share with you. That was in private chat. 78519854. 78519854. I cannot paste it in the chat box, but you can note directly. So let's move to the next question. Let's see. Let's now move to the next question. So, okay. So Chinmay, we need to press enter. We need to press enter for to show the question to the audience. Yes. So here is the question from Amazon. You people can try. So actually, this quiz is totally placement-based quiz. The question are only from the good software companies, so that it's not just remain a quiz for you. You will This will help you in the placements also. No doubt you are going to get the prize also, but with prize, actually the bigger prize is your placement. So that's why this quiz will be little bit tough, because these are questions actually from good companies, Amazon, Microsoft, Google. The question is going to be little bit tough. So 9 seconds left for this question. So time's up. So many people give the right answer. So let's move to the next question. Okay, let's move to the next question. So here is the second question with you people. This is from Walmart. The code is 78519854. 78519854. 78519854. Yes, can you please? I need your, I think, help. Can you copy that from the private chat? That code.
Oh, just give me a second. Yeah.
Yeah, time for this question. Three people give the right answer for this one. So let's move to the next one.
Yeah, code is visible in the chat.
So here is the code is visible to you people now. So this is the next question with you. This is from Flipkart. So please give a try. Even though you are not giving the right answer, but you are at least getting familiar with the questions. These are questions from good companies actually that will help you in the placements. So Sankalp is doing 1, 2, 3, 4, and Chirag sir ki jai jaikar. 1, 2, 3, 4. I have to read like this.
Right.
So now the code is with us. So here is the code. Think about it and then try to solve it. Don't worry if you are not able to solve because these questions have some level. Don't by heart from that. Yeah, maximum people give the right answer. That's clapping from my side actually. Okay, let's move to the next question. So here is the next question with you people. This is from Adobe. Please give a try. If you will attend these sessions, at least you will get familiarized with these questions. And then later you can work over that. You will check, at least you will be knowing the level of these companies. Okay, what type of questions, what is the level of their questions? You will be knowing that. So time is
So
almost
time
up.
is almost up.
Let's see how many
Let's see
people
how.
give the right answer for this. I think maximum people give the right answer for this. Well, let's move to the next question. That's nice to see actually. Let's move to the next question now. So here is the fifth question with you people. Mm, yes, that is from a Cloyd. So you can take time. You have 1 minute in this question. You can think over it. Still, you have 30 seconds with you, or 20, 15. Or time over. Let's see how many people attempted it right. Few people, very few people attempted it right actually. This question. Let's move to the another one. Here is the sixth question with you people. This is from Microsoft. So check out if you can attempt it or not. If you are not able to attempt it, don't worry at all. At least you are familiarized with the question. Still, you are learning. And at the end, you are getting the gift also from the coupon from the gigs or gigs. Geeks for Geeks is our friend actually that is helping us. You have 10 seconds with you. So time's
So
up.
time's up.
Let's see. Hmm.
Hmm.
So maximum people
So
give right.
maximum people give right.
That's nice.
That's nice.
अच्छा कमेंट हटा दें. चिराग सर का फेस देखना है. लेट मी पुट योर कमेंट हियर. चिराग सर का फेस नहीं दिख रहा, कमेंट हटा दो. Who want to see the Chirag sir face here? Okay, so this is the last question with you people. So you are actually. So let me hide. Let you can see now Chirag sir face. Okay. So this is the last question from Accenture. चिराग आपको काफी प्यार करने वाले हैं यहाँ पर ऑडियंस में.
Yes, sir.
Okay, so this is the last question with us, and let's see. Hmm, three people actually give the right answer. Don't worry, not by heart. These are just for the improvement. Okay, let's see who is the winner now. So let's see our ladder board, and here Bell is the winner. Yes, and
Yes.
Mohammed is the runner. So, okay, you people, Chirag and Yash, I will stop you for 10 seconds. 10 seconds, I will take your 10 seconds. Please stop for 10 seconds and let's celebrate with 10 claps. Let's congrats to the bell for 10 seconds for 10 claps. Please join with me. Please join with
Uh,
me. So this was the so Bell is the winner from the audience. So these questions are not actually that much easy. Attempting these questions is not that much easy. That is showing your level also. Okay. So thank you, Chinmay, also for helping us to show this quiz to the audience today. Actually, thank you, Chinmay. Okay.
yeah.
So
So my code is complete for this particular
go
question.
with the your okay. Let's go with the Chirag first. Chirag, have you completed your code?
Yes, sir, I
Or
have
still
I
completed,
have
but
completed, but
I'm just like
I'm just
sorting out one thing. Like, I think I have written the code correctly, but not getting the output. So I'm just sorting it out for the last time. I'm just iterating over it. So it will be
okay.
great if you can go
Okay,
with yes first.
let's go with the Yash then. I think Yash is was very comfortable with this question also. Yes,
like
Yash.
final trees are quite easy for us.
So I shared
So
your
is it?
screen. Now you can show your. You can first let's
Yeah,
run your code
yeah. You
and
can.
let's check out
What was the test case? 113 and then
113 and let me check out in my PPT. So 113 and 221.
221 and then
Okay, three
for
inputs you want. Three.
let's see for two inputs first. Like if you
This output should be 4.
let's just give 4 minutes. I'll check it for two inputs. Output should be four. I think it would be four. Yes, I'm getting output four.
So let's check. Let's take some input from the audience also. Anyone, please, will you please provide the input, any input, so that we can fail actually yes code. Any input for which do you think we can fail the code of the code? So meanwhile, I have one more input for you. You can
Yes,
enter that one. 113,
yes,
215,
215
and
and then
221.
221.
Yes, that's three. Actually, three. These are three. Uh, you need to enter, I
Okay,
think, three
yes.
numbers.
So I needed to enter three. Just give me three
Yeah,
minutes.
and output must be 12 actually.
I think it would be 12. Yes, I'm getting 12.
So okay, that's great. Okay, can you please explain your code only? Now we want to focus only on the code. Can you please tell us,
Yeah.
explain the code?
Right. So in this particular question, what I basically did was, if someone has joined, so they can just move back after this stream is over, and they can see the logic part that I explained. Basically, I'll be taking n nodes as an input. I have taken a vector. You can take an array or a list, that depends on you. So all the nodes will be represented in a three digit number. So I'm storing all the n nodes, all the three-digit numbers in an array, and then I'm passing all of them into a function in which I'll be calculating all the path sums, right? So what I'm doing is I'm passing the vector A, which is containing all the nodes information, that is all the three-digit numbers which are representing the nodes. And from this function, what I'm getting is I'm getting the sum. I'm getting the sum of all the roots to the leaf path, right? All the path from root to leaf. I'm getting all this sum, cumulative sum. So I'm simply printing the sum. So let's see what I have done in this function. So what I've done is, like, as I told you, like, let me just little bit of brief. Up till now, if things are clear to everyone, like, all, at least those who were present earlier, I just wanted all of you to be a little bit aware, right? So if I had this thing, right, if I had for a particular given value, right, for a particular given node, right, I had three informations, right? Uh, I had its level, I had its position, and I had its value, right? As I said, that if I had decoded a thing, that is, if I am at the parent, if my parent's position is pause, right? If my parent's position is pause, then as I said, that my child's position would be pause two times pause minus one plus one, the left child's position, and the right child's position would be two times pause minus one plus two, right? This would be the positions that I had made. You can also, like, if you choose pause, and then you can also make two times pause minus one or something like that. But this is how I decoded it. Like, if I were to tell you about this, so just a little bit more. So just give me a second. I'll just erase this part and let you know. So if you
Yes,
will observe, like, yes,
yes. Don't repeat anything. People are saying हमको नींद आ जाएगी if you will repeat the things.
okay, right. So, like, as I said, like, what you will be doing is, you are given three things about tree, like level, you are given pause, and you are given value, right? So what you can do is, I could make a adjacency matrix. Like, why I could make an adjacency matrix? Why not an adjacency list? Because here, sir has mentioned that the levels would be from 1 to 4, right? Sir has mentioned earlier that the levels would be from 1 to 4. So that means I can take five, like, I can make this, right? And the positions would be till 8, right? Sir also mentioned in the earlier that the positions would be 8, and the reason for that is, I think, because the levels are 4, right? So if there are 4 levels, so on the very first level, there would be one node. On the second level, there would be two nodes. On the third, there would be four nodes, and on the fourth level, there would be 8 nodes, right? So total 8, right? So I can declare a vector. I can declare a vector. I can declare a 2D matrix, right? I can declare a 2D vector, you can say. And in that vector, what I can do is, I can make it like v of 5. What and then maybe I can say 9, right? This is maybe I can make it as 10 for security purpose, right? So I can make it as 10. And what I will do is, like, this will be telling me about the level, and this will be telling me about the position. Now, what will how will this help me? So if I make a vector like this, if I make a vector of level in which I have stored the level and I have stored the position, and it's equal to the value, right? It's equal to the value. Let's say I have used all these three parameters. So for identifying a particular node uniquely, I wanted to know its level and as well as position, right? As I mentioned earlier. And I'll for that particular level and position, I'll know that that particular node is present there, right? As I said, like, if I have, let's say, something like this, right? If I have something like this, uh, this thing, right? So if I have this particular node, let's say this is what this would be something like, let's say, 3 3 and something like 4. So this node's value is 4. It is present on the third level. This is the first level. This is the second level. This is the third level. So its value is 4, right? So like this. So it would be stored like this. Once it is stored, so as I said, if my parent's information, if in my parent, the level of the parent is, let's say, level, and the position is pause. So what I can do is, if I want to move towards its left child, then I'll increase my level by 1, and the position would be 2 times pause minus 1 plus 1, and similarly it would be from the right child, right? This is what I'll be doing. So in this way, I can store all this in the adjacency vector, and then I'll be able to iterate through, right? And if there is a child such that his level plus 1 for a particular child, if the level plus 1 and the 2 times pause minus 1 plus 1 or 2, right? Or 2, if it is equal to minus 1, I'll initialize the vector initially to minus 1. If for a particular parent, if its left child and the right child is equal to -1, so that would simply mean that, as you mentioned, that the values that a particular node will be having will be between the range 0 to 9, right? 0 to 9. So since it will be in the range 0 to 9, so that is why what I can initialize it to -1. If a particular if the both the left and the right children of a particular node, which is standing at the level L and the position pos, if it both its children are -1, left and the right child are -1, so that would simply indicate that that particular node is a leaf node. And in that case, whatever sum I have calculated up till now, I'll simply add this to my ultimate answer, right? Answer plus is equal to sum. This is what I will do. So this is how I'm thinking. Let me show you my code part. So what I've done is, like, as I said, I've made a vector. I've made an adjacency matrix, because adjacency matrix, making a adjacency matrix was easier for me. So this is what I've done. Then I've initialized all the values to -1, indicating that if a particular child is not, if a particular node is not present, so it will be, its value would be -1, right? Then n is the number of nodes. So I'm iterating for each node and I'm storing all the information, right? So I'm extracting all the digits. So what I'm doing is, my z of 0 is storing the value, right? What I'm doing is, my z of 0 is storing the value. My z of 0 is storing nothing but the value of the node, right? And because this is the very first digit that I'll be extracting, right? And my z of 1 is storing the position, right? And my z of 2 is storing the level, right? This is what I have done. So this is what I've done. Now all this information will be stored in my matrix, right? Up till now, if things are clear, so you can give me a plus one in the chat, right? Now what you will be doing is, you make a queue, right? I have made a queue. I have used a vector. The reason for that was because I wanted a level. I wanted the level. I wanted the position, as well as the sum up till that particular node, from the root up till that particular node, whatever is the sum, right? Whatever is the sum up till there, that I wanted. And I always, whenever I start a BFS or a DFS, I have used a BFS, and you could also use a DFS. That depends on your choice. But I used a BFS just to stay simple, right? So what I did was, like, in the queue, I pushed the node, the what is the my first node, starting node. So starting node is nothing but the source node is 1, right? The source node is the very first node, and its level is 1, and its position is 1, and its value is v of 1 1, right? This is what its value is. So I'll push it, and then the simple template for binary search, that is while you can say queue dot size, right? Up till the queue is not empty, or you can say not a queue dot empty, whatever you can say. So in the current, I have stored the queue dot front. I have popped the node out. I have popped the current node out, and what I'll be getting, my this vector in which I am storing three values, right? In this, I am storing three values. So the first value at the 0th index will be indicating the level of the current node. The curve of 0 would be indicating the current of the current node, right? This will be indicating the level. The current one, that is the second element, would be indicating, second element that is present in the current vector would be indicating nothing but the position, and the sum will be indicated by the sum up till this point. Sum from the root up till this point will be indicated by the third element, right? That is indicated by current of 2. And I've marked my leaf as 1, indicating that I'll say that I have a leaf is equal to 1. I'll, like, initially I'll think that maybe this is the current node that I am at, it is a leaf node, right? I'll initially think that it is a leaf node. So what as sir has mentioned, that the level should be lesser than 4. Why I'm sir has mentioned that the level should be between 1 to 4, but since it will go in a zero based indexing manner, so that's why I'll take in level as less than 1, less than 4. If the level is lesser than 4, and the particular child is existing, right? If what is the left child, so if the level is less than 4, so that means it is a valid child, right? And if the level is less than 4, so if the level plus 1, what is its left child level? For left child, I'll go to level plus 1, I'll go one level down. And as I said, like, I was using a formula that is 2 into cos minus 1 plus 1. So that's why I'll be able to access the left child. If the left child is not equal to -1, so that will mean that the left child is existing. And if the left child is existing, so I'll mark the leaf indicator variable as 0. If I'm marking the leaf indicator variable as 0, so that means that if for the current node, if its child is present, so that's why it will never be a leaf node, right? If this leaf node is still 1 by the end, so that will mean that it is a leaf node. That means that you will never go into any of these, right? So if this particular is not a leaf node because it is having a child, so it will never be a leaf node. So I'll mark the leaf as 0. And in the queue, I'll push level plus 1. I'll push the position of the current node, that is this node, 2 into cos plus 1, and I'll push the sum, that is up till now whatever I had the sum, and uh, the sum of the current node, right? That will be nothing but v of level plus 1 on 2 times cos minus 1 plus 1, right? And similarly, I'll do it for the right child. If the right child is existing, so it will never be -1, because it would be, because the values are between 0 to 9, 0 to 8 or 9, something like that. So if the leaf is 0, so in that case, if the leaf, like I'll mark the leaf as 0 because this will never be the leaf if the current node child is existing, so it will never have a leaf. And if I never go into any of these ifs, so my leaf will still remain 1. And if that is the case, so that means that the sum of that I've calculated from the root up till this node is, since this is the leaf node, so that means this the sum that I've calculated is the sum from the root until this leaf. So that's why I'll add it to my answer, and in the end I'll simply return the cumulative sum of all the answers, right? Is this part clear to everyone? You can give me a plus one in the chat if this much part is clear to everyone, right? If this much part is clear to everyone, you can just give me a plus one in the chat, or you can also like the video, right? So since I was using a BFS traversal, so I think the time complexity of my code, like I wasn't using any other thing, so I think the time complexity of my code would be order of n. Why? Because I'm iterating through each node exactly once, like from a particular, like say, if this is my tree, then what I was doing is, suppose this is my tree, so this would be the first part that I'm iterating. So I'm iterating through it once. I'm iterating through this part exactly once, and the third part also I'm iterating through each node exactly once. So it would be order of n. Time complexity. And talking about the space complexity of my code, so the space complexity would be order of n. Why? Because I am like it would not be. It would be order of n. The reason is it would be something like order of n into, like it will still be very much less because the constraints are very low. It would be something like level into what? Level into the positions, right? So that would be the time complexity of my code, space complexity of my code, right? So it will be very much less, but because the constraints are very low, right? Is this part clear to everyone? I hope that the explanation of my code is clear
Okay,
to
okay, okay. That's nice. That's nice. Yes. We are moving to the now to the Chirag. Chirag, please present your code.
Okay, so sorry. I think my screen is visible, right?
Yes. You need to increase the font little bit more. Yes,
I
that's
think
fine.
it's fine.
Yes, yes. So you just
Yes.
explain just explain. Let's first run your code. Okay, then we will move.
Okay,
Let's
okay.
check out your.
Hmm.
If in
So,
the audience if somebody want to give the test case, then they can provide us. Otherwise, meanwhile, I am providing you one test case. So there are
yes.
actually three elements in the array. That is one. First one is 113,
Yes, sir. 113
215,
and 22
and 221.
221. Okay.
So the output should be 12 actually.
So it is 12.
Okay, okay, that's fine. Uh, I think there is no input from the audience side. Okay, so you can explain your code. How?
Okay.
What was your approach? Okay, tell us about the approach.
Okay, so the approach that I used was very similar to as Yash said, right? But instead of BFS, I have used other approach, right? So the thing is
Okay,
that because you have to iterate through each node once, and you have to utilize the given information, right? So what I did basically is that in the main function, similarly, I've taken the input that the size of array that I want, and I have used a vector. You can use any specific or respective data type that you want, and in that vector I have pushed all the values, and then I have used a sum function, right? So the sum function will return me the path sum of all the paths that I'm having in my tree, right? So the first thing, or the first hurdle that I was facing is that how I can retrieve the values, or how I can connect the given array in the form of a tree, right? So as yes that there are the things that you can use, like 2 into position minus 1 plus 1, right? To check the left child and the right child, right? To get the position of the left node, or left child node, or the right child node, right? So the same thing I've used. So in the sum, you can see I have used an int answer equals 0. In the answer variable only I will get my final answer, and I have called a function here solve, right? So all the mystery, or all the thing that I have implemented resides in this function only, right? So let's see this, right? So in this function you can see I have taken 5 inputs. The first one is that particularly input integer, input vector only. Then second thing is index, right? that currently what is the index of the node, right? And index in particularly that array or vector, right? Third is the sum, right? That what is the current sum. Fourth is the answer. Answer is the main variable in which I will be keeping the answer. And fifth is the depth, right? So these all are the information of the current node that I'm having with, right? So what I will do, I will iterate through each and every one, right? So the first thing is that the first node that I particularly started with was the root node only, right? So the root node was having its index value 0, right? The some value is value 0 mod 10, right? So now the question rises that why mod 10? So as it is being given that in the given integer, the last digit, the ones that we are having in the position, in that we are having the value, right? So to retrieve that, well 0 mod 10 was the option, right? So here's the sum, here's the answer, and here's the depth, right? So in the given example, in the given diagram that I saw that sir has presented in the starting of the session, was that the first was it was level 1, then it was level 2, then it was level 3, right? So this is how it was going, right? And one thing that you have to keep in mind, that I have kept the zero based indexing, right? So so this is the node, this is the for the root value, and we have started with that, right? So we have all the things here, right? So now let's start that we are over the first root, the node root, the root node over now, right now, right? Now what you have to do, you have to see what is the position of the left node and what is the position of the right node. So Yash has explained quite well that why it will be 2 into position minus 1 plus 1 and 2 into position minus 1 plus 2. By you can just imagine in your head, right, that if here is the root and here will be the first position, here will be the second position. So if there is if it is 1, so it will be 2 and 3, right? So it will be 2 into 1 plus 1 and 2 into 1 plus 2, considering 0 and 1. So that's why I have put minus 1 here, right? So this is how it will work. So as as a time has crossed its limits by a significant amount, so I will not go deep into that, right? So next what I have to taken is child equals 0. So this will keep counter over that if it's a leaf node or not, right? So I will explain that how this is mattering the situation, right? And then what you have to taken is int d and int pos. So d will be representing depth, and pos will be representing position, right? So now what you have to do, you have to iterate through all the rest of the nodes. So one thing that sir has mentioned in earlier is that the array is being sorted, right? So you can see that in the given input also, it is 113, 215, and 221. Why? Because the first index is the depth, the second is the position, and third is the value, right? So the depth will be one first, in the second depth, then the third depth. And at each level, right, the depth or the level, right, at each level there will be multiple nodes. So that are also in order. Suppose in the first level, obviously there will be one because it's a binary thing. In the second level, there are two. So it's one and two, right? So 1 and 2, so it's in ascending order. So this is the matter that I have taken like advantage of. So if I have completed this, then the rest of the nodes will be lying in front of that only, right? So what I have gone is from index plus 1 to the size of the particular array. Now so d will be, so what is d is particularly depth of the level. So it will be value divided by 100. Why? Because the 100th position that I'm having is on that only the value depth or level is being residing, right? And for pos, we will be having well I divided by 10 modular 10, right? So I don't want to go deep in this, right? But this is how you will, this is how you retrieve if you want a single value from the whole number, right? Now the thing, the main thing that forms the logic is here only, right? So this is the part you have, what you have to understand quite well. Now it is being given if d equals depth plus, right? So what is
I
that?
think
What
it's
is that?
very similar. Like we can that it is taking too much time, so maybe we can just explain it a little bit fast.
Right. So basically, what I did is I explained you that depth is the position of the current node, and what I'm doing is I'm going to all the further nodes that I'm having. For suppose I was on level 1, so I will check all the nodes on level 2. When I will be on level 2, I will check all the nodes on level 3. So what I will do, I will check that if I'm on the level 1 node that I have passed actually 1 here, right? So depth is 1 right now. Now if d is 2, so 2 equals 1 plus 1, right? So this condition matches, as well as this left position is equals to position, or right position equals position. What this means is we have calculated these positions, right? So what will be the expected position if it forms a binary tree? What will be the expected positions of that particularly left or right? So if any of the position it matches the position that is being given in our given vector that we have taken input from the user, right? So if this matches, it simply means that okay, this is the particular node or this is the right node that you are going to. So what we will do, we will check is child equals 1, and we will go further for solve well I sum plus well. So here is the main game. We will add the value, right? So again on the ones place, so what you have to do, modular 10, right? So you have to add the value in the sum, and all the things will go on, and now the depth will be 2, right? So in this manner you will find, and this is the breaking condition, that if it is greater than the depth plus 1, so you don't have to go further, the tree is empty. And after iterating the whole thing, right, so there might be some conditions where it will not match or it will end, right? So what that will signify, that will simply signify that it's a leaf node. So in the case of leaf node, your child will be 0. So earlier I said that why I am using this is child variable. This is only because I have to I have to take counter if it's a leaf node or not, right? So if is child is still 0 after the loop, that means it is a leaf node. So what you have to do, you have to do answer plus equals sum, right? So here what we will do, I will iterate through the whole thing, and if I got a leaf node, I will add the sum to the answer, right? Then I will go back again, and then I will find the similar ways, right? So this is how it is being calculated, and we have returned the answer here, and we have printed the answer here, right? So I think that's pretty much it.
Yeah,
Pretty much.
yeah, that's nice to see that. Okay, you use even you were knowing the approach of the yes, but you use your own different approach. That was nice to see. But the complexity I can see is again going to order of n in your code also. That
Yes.
is not going less than order of n. So the yes code complexity is also again order of n here. Okay, let's wind up this session now. So before winding up, let me tell to the audience that okay, we if you want to participate in this competition, if you want to come here live in place of Yash and Chirag, you want to solve the problem, coding problems here live, then their form is available in the description. You can check out the form and you can fill that form. If you want to participate live here in the next week or next to next week, then you can fill the form. Okay, so that is available for you people also. If you are good at competitive programming, we will prefer you to be here. We will like that. Okay, if you are joining us, no problem. And if you are not good at that, then there will be less chance. If you are good at DSA, then we can think over that. Okay. So every Friday, the session remains on Coding Battleground. Though for those who are new here, every Friday that remains near about 6 and 7 o'clock. Okay. Okay. So let me wind up the session. So from our audience side, the winner is Bell, and runner-up was the Mohammed. So congratulations for them. And from our coder side, actually, the complexity of Chirag and Yash is same order of n, and so we need to go to our second factor. So whoever will submit the code earlier, that will be the winner. So Yash submitted the code earlier. So in this, even though code both of doing the code better, but Yash submitted the code earlier. So Yash is the winner from my side actually. Congratulations, Yash, and best of luck, Chirag, for the next time. You
Thank
have
you.
also done given us another approach to solve the same problem. Thank you for that thing. Thank you,
I,
Yash, for
I'll, I'll just
next.
request the audience to like the video. Like we had some technical issues, but still we were able to conclude the session. So in the audience, everyone can just hit a plus one in the chat for Puneet sir because he had tried a lot, and all of you can just like the
For
video and
yes,
hit.
for
They
yes
can
also.
just give a you can just give a plus one in the chat so that we are encouraged to bring more sessions. And Puneet sir has been asking good questions, so you can attend those sessions like in the future as well because the quizzes I see, so like it will be helpful in your online rounds and things like that
Yes.
placements. Right? You can write like the video and like Puneet sir can take over.
Okay, in the next week we will meet on again on Friday. If you are interested, you can fill the form in the given in the description. If you want to participate, come here live. Okay. Okay. Thank you, everyone. Stay safe. Thank you.
Thank you, sir.